Okay, guys, so this is something that I've been putting off because it sometimes can be difficult. And I've been trying to find easy stuff to do in physics, but I've run out of stuff. So we're going to do angular motion. But I'm going to break it down into several small lessons. We'll take it nice and slow. Okay, so things you need to know. 1 revolution is equal to 2 pi radians, which is equal to 360 degrees. We all should know that from calculus or pre-cal. The formula for arc length is S is equal to R theta, where S is your arc length, R is your radius, and theta is your central angle. Now, it always has to be in radians. That's important. V is equal to R omega. That is omega. That is not W. That is omega. V is what we call the tangential velocity or the linear velocity. R is your radius, and omega is your angular velocity, and that's given in radians per second. The tangential acceleration is equal to R times alpha, where alpha is going to be your angular acceleration. So tangential acceleration is so say you have a circle and it's going like that, so it's going to be what it flies off tangent to the circle. Okay, so if I was spinning a bucket above my head, it would fly off tangent to the circle. Okay, and some other formulas. The centripetal acceleration is equal to v squared over r, which is equal to omega squared times r. Okay, so we might not use the acceleration stuff too much today in this week, but we'll get into it next week. Okay, first example. I want to convert 28 degrees to radians. So when I do conversions, I always write my given over 1, and there's 360 degrees to 2 pi radians. So I put that in the calculator. Don't forget the pi whenever you multiply. So 28 times 2 pi, and I'm going to divide it by 360. And let's go 3 decimal places. So it's 0.489 radians. Okay. Revolutions to radians. So I have 3 revolutions over 1. Okay, so 1 revolution has 2 pi radians. Okay, so your units should always cancel diagonally. So 3 times 2 pi is 18.850 if we round to 3 decimal places. Okay, I'm going to go 0.25 RPMs, which is revolutions per minute or rotations per minute, and I want to go to radians per second. Now, when we have a unit like this that's a rate unit, we always deal with the top unit first. So 1 revolution has 2 pi radians in it. Okay, and then I'm going to deal with the bottom unit. 1 minute has 60 seconds. Okay, so revolutions cancel with revolutions, minutes cancel with minutes, so I'm left with radians per second. So I'm going to multiply everything across the top, so 0.25 times 2 pi, and I'm going to divide it by 60. So I get 0.0262, and that's going to be radians per second. Okay, now on to the next example problems. Now we're going to start doing with some arc length. Okay, in this example problem, I'm given the arc length from here to here is 3. The radius is 2. So I'm looking for theta, my angle in radians. So S is equal to 3, your R is equal to 2. I'm looking for theta. So theta comes out to be 3 divided by 2 is 1.5 radians. In the next example, it gives you the arc length is 30 inches and the angle is 260 degrees. So remember, we always have to be in radians whenever we're dealing with this type of question. Okay, so we're going to do 260 times 2 pi, and we're going to divide it by 360. So I get 4.5 538. Okay. Now, I'm looking for the radius. So S is equal to R theta. Your arc length is 30. We're looking for R, and your theta is 4.538. So to solve for R, we're going to divide both sides. So 30 divided by, that gives me 6.611. And I'm in inches for my radius. Okay. Now a little bit of a word problem. It says a turntable goes through 17 revolutions and has a radius of 0.5 meters. What is the circular distance traveled along the circle in those 17 revolutions? So what we want to do is we need to convert 17 revolutions. So one revolution has 2 pi radians. So 34 pi comes out to be 106.814. Okay, so that's how many radians it travels. Now, if I want to find the distance it travels along the circle, S is equal to R theta. So I'm just going to plug in. The radius is 0.5. And I'm going to multiply it by the 106.814. And you get 53.407. And we are in meters because our radius is in meters. Okay. Velocity examples. It says a ballet dancer executes a pirouette at a rotational velocity of 40 rotations per minute, and her arms act as a radius of 1 meter. Find her tangential velocity. Okay. So tangential velocity, VT, if we go back to our formulas, is equal to R times omega. Okay. So our radius is in meters. We need to get this RPM to radians per second. So one revolution has 2 pi radians, just like we did before, and 1 minute has 60 seconds. So we're going to do 40 times 2 pi and divide it by 60, and you should get 4.189 radians per second. Okay, so our radius is 1, and our omega is 4.189. So VT should come out to be 4.189. And we're going to be in meters per second. Okay. A typical circular saw has a radius of 0.814 meters and rotates so the edge is moving at 110 meters per second. How many RPM is the saw making at those given conditions? Okay, so VT is equal to R omega. We have our tangential velocity, because it's moving at the edge, is 110. Your radius is 0.184. So we're looking for omega. So we put that in our calculator. 110 divided by 0.184 comes out to be 597.826 radians per second. Now, the question's asking you to get to RPMs, okay? So 597.826 radians per 1 second. We said that there's 2 pi radians to 1 revolution, and there's 60 seconds to 1 minute. Okay, so we're going to multiply across the top. So multiply by 60, and divide by 2 pi. Now, when you divide by 2 pi, it needs to make sure that you're in parentheses. Okay, so it's rotating at 5,708.819 RPMs. We're running out of room. Okay, so hopefully this was an easy lesson for you to do. It's just basic algebra calculations. Remember, omega is how fast something's rotating. The tangential velocity is, you know, the velocity at the edge of the circle when it flies off. The bucket flies, if I was to release a bucket that's flying over my head, you know, with a rope, it's flying tangent to the circle. Don't forget your conversions, and hopefully you understood this. If you have any questions, feel free to reach out. Thanks.